periodic table, notes page 53. We're going to take a look at the history and development of the periodic table, specifically at the two primary scientists who did the most work in developing it. So the first scientist that we're going to talk about is Dmitry Mendeleev, Russian chemist, little bit of a renegade and considered maybe crazy by his peers back then in the 1800s. But he's the first scientist to successfully arrange the 60 known elements into a table that now we refer to as the periodic table, and sometimes he is referred to as the father of the periodic table. The way that he went about organizing the elements is he took out index cards, wrote down the element names, wrote down physical and chemical properties known about these elements, and he focused on one property. And so he first took all of his elemental cards that he created and he placed them in order of increasing mass. And once when he had them lined up in increasing mass, he started to notice a cycling of properties among the elements. And those of you who are in band or music, you probably know the term octave. So about every octave among the elements, the next octave would have a similar set of properties, and he found this very interesting. And so he readily decided that properties were more important than mass when it comes to organizing the elements, and therefore he actually swapped some positions of the elements. So one example that comes to my mind is element 18 compared to element 19. So element 18 is argon, and argon's mass is actually slightly greater than element 19 that we refer to as potassium. So if order was dictated by mass, potassium would be 18 and argon would be 19. But comparing properties, argon has more in common with neon, that's just above it on the periodic table, and potassium has much more in common with Na, that is just above it on the periodic table. So the next thing that really put Mendeleev and his ideas on crazy, being a renegade, maybe we shouldn't allow him into our scientific lectures, was that as he organized these elements, he actually left empty spaces on his table for elements not yet discovered. And he went one step further, which his closest friends begged him not to publish his paper because they thought that he would never be allowed back in the scientific community after publication. But besides leaving empty spots for elements not yet discovered, he actually listed pretty darn accurately their expected properties. And the scientific community at that time thought that he was pretty outrageous. But probably within 10 to 30 years, some of the elements that he predicted their existence of. So let's list down 4 major examples. He predicted the existence of gallium, Ga, germanium, Ge, scandium, Sc, and technetium, Tc. And it was only a few years after he predicted the existence of gallium that what he had listed for gallium's density and melting point was right on the button, right on the money. So the next big scientist who helps to improve upon Mendeleev's periodic table is an English scientist known as Henry Moseley. He's a physicist, and he was a colleague and a student, and he worked on some of the same stuff as Rutherford and Bohr and Thomson. And what he looked at is he looked at X-rays that were taken of the known elements. And he started to study these, And from studying those x-rays, he actually determined the atomic number for each element. And so through his research and study, he said that the element arrangement on the periodic table is a function of, or is determined by, the atomic number of that element, and defined the atomic number as the number of protons. So if we write down a couple of examples, Mendeleev put H in the very first spot on the periodic table. Moseley looked at its X-ray, atomic number of 1 proton. Mendeleev put He, helium, in spot 2 on the periodic table. Mendeleev, studying his X-rays, helium, atomic number of 2 protons, 1 more. Mendeleev put lithium, Li, in spot 3 on the periodic table. Henry Moseley looks at the X-rays and studies it. Lithium's atomic number is 3 protons. So order is determined by the number of protons, or the atomic number. As a result of studying those X-rays, determining atomic number, we come to the periodic law, which simply states that elements are arranged in the order of increasing atomic number, or we could put above that, number of protons. There is a periodic cycling of elemental, physical, and chemical properties. So physical properties that we might see cycling or patterns about would be phase, density, melting point. Chemical properties that we would see patterns in would be the type of reactions that elements participate in, the number of bonds that they are able to form, the type of compounds that they are part of or used to make.